For every action, there's a reaction. Have you ever wondered how anything moves? It's a great question. The answer is all around us in everything we do. Sir Isaac Newton, a very clever scientist, figured out some amazing rules about how things move. We call them Newton's laws of motion. Today, we're going to explore his third law, which is super cool and maybe a little surprising. It's a fundamental principle of physics, which is the science of how stuff works. This law helps us understand the universe from the smallest push to the biggest rocket launch. It's an idea that once you get it, you'll see everywhere. So, what is this famous law? Newton's third law of motion says, for every action there is an equal and opposite reaction. Think about that for a second. Equal and opposite. This means that forces always come in pairs. You can't just have one force all by itself. Whenever you push on something, that something pushes back on you with the exact same amount of force, just in the opposite direction. It's like a cosmic rule of push and pull that never, ever gets broken. It's not just a suggestion, it's a law of the universe. Let's break it down. An action is just a force, like a push or a pull. The reaction is the force that pushes or pulls back. Imagine you're leaning against a wall. The action is you pushing on the wall. The reaction is the wall pushing back on you. If the wall didn't push back, what would happen? You'd fall right through it. The reason you stay upright is because the wall is giving you an equal and opposite push. It's a perfect balance happening all the time, even when you don't notice it. This might sound a little strange at first. If the forces are equal and opposite, why does anything move at all? Why don't they just cancel each other out? That's a fantastic question. The secret is that these forces act on different objects. When you push the wall, the force is on the wall. When the wall pushes you, the force is on you. Because the forces are on different things, they don't cancel out, and they can cause things to change their motion. It's a beautiful, elegant system that governs everything in our physical world. Let's think about something you do every single day. Walking. How do you move forward? You are actually pushing the ground backward with your feet. That is the action. According to Newton's third law, the ground must then push you forward with an equal and opposite force. That's the reaction. It's this forward push from the ground that actually moves your body forward. So the next time you take a step, remember you are pushing the whole planet Earth just a tiny bit, and the planet is pushing you right back. It's a dance between you and the Earth. Now let's try jumping. To jump up, you don't just lift your legs. You have to bend your knees and push down hard on the ground. This powerful push on the ground is your action force. In response, the ground exerts an equal and opposite reaction force, pushing you upward into the air. The harder you push down, the stronger the ground pushes up, and the higher you jump. It's not magic, it's physics. This simple principle is the same one that allows basketball players to slam dunk and gymnasts to fly through the air. This law isn't just for things on Earth, it's how we get to space. Consider a rocket launching. The rocket's engines burn fuel and shoot hot gas out of the bottom at very high speed. This powerful downward push of the gas is the action. The equal and opposite reaction is the gas pushing the rocket upward. It's this continuous, powerful upward push that allows the massive rocket to overcome gravity and soar into the sky, eventually reaching outer space. A rocket doesn't push against the air, it pushes against its own exhaust gas. Even something as simple as swimming uses the third law. When you swim, you push the water backward with your hands and feet. This is the action. What does the water do? It pushes you forward. That's the reaction, and it's what propels you through the pool. The more water you can push backward, and the faster you push it, the faster you will move forward. Every stroke, every kick, is a perfect example of Newton's third law in action. It's a universal rule that makes so much of our world and our activities possible. Now let's switch gears a little bit. Besides his three laws, Newton also helped us understand motion with math. Scientists use equations to describe how things move. These are called the equations of motion, or kinematic equations. They help us calculate things like how fast an object is going, how far it has traveled, and how long it took to get there. They are like a toolkit for solving motion puzzles. Think of them as recipes for predicting the future, at least when it comes to a moving object. There are a few of these equations, but today we're going to focus on a very useful one, the third equation of motion. This equation is special because it connects an object's final velocity with its initial velocity, acceleration, and the distance it travels. What makes it so handy is that you don't need to know the time. Sometimes, in a physics problem, you know how far something went, but not how long it took. In those cases, this equation is your best friend. It helps you find the missing piece of the puzzle without worrying about the clock. So what does this magical equation look like? It is usually written like this: v squared equals u squared plus 2as. It might look a little intimidating with all those letters, but don't worry, we can break it down. The v stands for the final velocity, or how fast the object is moving at the end. The u stands for the initial velocity, or how fast it was moving at the start. The a represents acceleration, which is the rate at which the velocity changes. And finally, s stands for the displacement, or the distance the object has traveled. Imagine a car that starts from a standstill and speeds up. Its initial velocity, or u, would be 0. As it accelerates, or a, over a certain distance, or s, its final velocity, or v, increases. This equation lets us calculate exactly how fast it will be going after traveling that distance, without ever looking at a stopwatch. It's an incredibly powerful tool that engineers use to design cars, and physicists use to understand the motion of planets. It's math that describes the real world in a very elegant way. So where does this v squared equals u squared plus 2as equation come from? It's not magic, it's derived from two other simpler equations of motion. Let's build it step by step. The first equation we need is the definition of acceleration. It tells us that final velocity equals initial velocity plus acceleration multiplied by time. We write it as v equals u plus at. This equation connects velocity, acceleration, and time. It's the first building block for our derivation. It's a simple, logical relationship that forms the foundation of our work here. The second equation we need describes the distance traveled. It says that distance is the average velocity multiplied by time. The average velocity is just the initial velocity plus the final velocity, all divided by 2. So the equation looks like this: s equals open parenthesis u plus v close parenthesis divided by 2 times t. This equation connects distance, velocity, and time. It's our second key ingredient. With these two equations in hand, we have everything we need to derive the third equation of motion. We are now ready to combine them in a clever way. Now let's do some algebraic substitution. Our goal is to get rid of the time variable, t. We can start with the first equation, v equals u plus at, and rearrange it to solve for t. By subtracting u from both sides and then dividing by a, we get t equals open parenthesis v minus u close parenthesis divided by a. Now we have an expression for time that we can use. This is the key step. We've isolated the variable we want to eliminate, which will allow us to substitute it into our other equation and create a new relationship without time. For our final step, we take this expression for t and plug it into our second equation, s equals open parenthesis u plus v close parenthesis divided by 2 times t. This gives us s equals open parenthesis v plus u close parenthesis divided by 2 times open parenthesis v minus u close parenthesis divided by a. Now we just need to simplify it. Multiplying the terms in the brackets gives us v squared minus u squared on top and 2a on the bottom. So, s equals open parenthesis v squared minus u squared close parenthesis divided by 2a. To make it look like our final equation, we can multiply both sides by 2a, which gives us 2as equals v squared minus u squared. Finally, by adding u squared to both sides, we get our beautiful third equation of motion, v squared equals u squared plus 2as. Science is amazing.